here push it out to the flex test, but I think in your application you probably want to do it the other way, if anything.
That's like a major question.
Yeah. Yeah. And then counters would be like cycle counting, channel counters, things along those lines. Variables. So variables we can set up for either user input to impact calculations or other internal calculation changes, more or less.
Is that like if you want to like have another column for the stress calculation, we would take a signal, divide all those outputs by like an area, something like that?
You could, yeah, you could potentially do something like that with it. Yeah, yeah. It's a little bit of a open box as far as the calculations and variables goes. It's I think the way that I've seen it used, I haven't used it extensively, but I think the way that I've seen the calculations be used with the variables is if you don't want to be infrequently changing the text of your calculations, instead you just populate, okay, this is an area variable that I want to change, a volume variable that I want to change, a length that I want to change, instead of commenting in your calculation, hey, change this if this. But that's probably, it's not restricted necessarily to that, but it's probably a large portion of the use. Detectors, I don't know if the detectors are going to mean a lot. So typically, just like on the flex test side, you're doing control, your limit detectors are there to protect things. Here we're not doing controls, so your limit detectors, you can have them set, but if you start to have things trip, you would want to be very cautious about what actions you have set from those limit detectors, because it may disable that acquisition. You're halfway through your test and things have now stopped on one side that you were depending on.
We would never use that.
So
Basically, as soon as we hit run, it's going to go continuous through the whole test. Nothing's going to be. We're not looking for anything. Very rarely we'll have like a situation where we want to speed it up during a certain window, but typically it's all going to run the same speed through the whole test for however many minutes, 10 minutes, 5 minutes. So it'll never be looking out for anything else or looking for signal input.
It's like control. Yeah. Let's see, like
possibly your control. Yeah.
Upgrade at some point.
Right. I'll just mention that they are there. And then recorders, so the dead acquisition channels and the recorders are probably where we'll live. Recorders helps define our dead acquisition rates, more or less what it is. So we'll just do a high level, I'll come back and we'll start playing with stuff. I won't define those yet. And then timers, I haven't actually used timers. So that's something I'll have to look at. And then events, similar to the command stuff up here, there's a lot of events that are kind of replicated. Well, but it could be used for control, but I think we'll end up using some of the events and commands for being able to trigger acquisition, trigger things from something that happens. So like if you use the event actions in 793 at all, maybe?
Event actions as far as like triggers.
You can usually trigger them based on digital inputs, and then you can have some or limit
I mean,
things.
we look for forces or displacements on certain sensors.
Okay. Well, maybe
And then we will change to a different segment in the procedure, but.
Okay. I guess I've used event actions within 793 before to pop up messages in the log or interlock or program stop or various other actions based on something. Usually I have calculations set up that are doing something odd. Maybe MPT was looking for something. I have a real-time calculation running, and then when something happens, something accumulates, I can pop up a message or stop the procedure. So this is kind of a way to do get more interaction. You can have something come in, know I need to now take a burst mode scan, take a start acquisition, stop acquisition, something along those lines. So the commands and events.
We'll have like a hold condition where we did that with, was that calibrating something?
Yeah, we basically have a setup where we went at certain force levels and we would hold it for like 10, 15 seconds.
At a certain force,
Yeah.
but the data acquisition would never change. I do see a mode change or an event change where if we're doing something on the seismic table and it reaches like a certain frequency in the motion, then we would probably speed up the data for like a couple seconds or a second or something. But that's down the road.
That would probably be like the burst mode or something.
Yeah,
Yeah.
that could be something like that. Like if you have a general acquisition rate and then you know you're going to hit a certain area, or if you had a calculation paying attention to frequency, it might be kind of tough.
You
But
could do like a watch signal, right?
But we would be bringing in a signal from the flex, the FT60 into this guy. Though.
as a trigger,
Yeah.
yeah. Okay. So that's kind of the stuff to play with on the right-hand side, so the test. So we've created a test. Now we need to tell the test what do I actually care about. So we have these. Oh, and we have to actually do our calibrations. So we have these sensors on this side. We don't have any data acquisition channels yet. We haven't set up our recorders, and potentially our triggers. So let's say I want to actually use the sensors. Now you can, there's a multitude of different ways, just like with the
drag and drop was one of the ways.
drag and drop is easy.
I
So
like that.
yeah, so if I pull strain gauge 1, or I could pull this whole group. So if I pull the whole group over, it will use the names that are within these and name them accordingly. If I drag and drop them individually, it uses the names. If I was to use the wizard over here on this side of things, I think the wizard, which I find really weird, the wizard goes to the hardware inputs, not the sensors, in which case the names are somewhat arbitrary, which then you'd have to go back through and rename them. It's kind of clunky. So it's probably best if we just said pull from the whole group.
That's probably what we
Pull
I
over
see
here.
it doing.
Yep, and so now we got 1 through 4, so they're named the same as what's going on this side. Now, other small details, but they become important. I pulled LODSO Group 1 over for data acquisition channels. You notice there's a little X on top of the icon now. You notice down here in these ones, because I haven't done anything with any of these, there's no X on top of the box. Yep, so these are currently being used in a test. Otherwise, these are assigned, but not used in a test. These are not assigned and not used in a test. So those little icons are giving some indication of what happened. So they're over here in the test. Now, the easiest thing to do, so if I double click on this, okay, brings up this larger menu of information. This is where we can do full scale ranges, we can set limits, we can play with our conditioning, our excitation voltages, offsets, filters, calibration information, all the different calibration methods. Comparison doesn't really make a ton of sense with this, but compensation, if we were doing temperature compensation with inputs, we can do that here. We can view our input resources and review limits. Again, limits doesn't really make sense for the tests with this being data acquisition only, so it's probably not that
So
beneficial.
this will read thermocouples?
Not natively, no. This would be if you conditioned a thermocouple externally as a voltage input.
Amplifier before it goes in there?
Yeah, right. I think we do support some other equipment. I think it's the popular ones, the VTI 1629, I think is the thermocouple input. And I think that's another network or another driver that we support into AeroPro as thermocouple inputs, high channel mounted in. So I double clicked on this guy to get that to pop up. What you might want to do, so if you right click on this and go to pin to app bar, that pins that folder up here, and now you have access to it whenever, because that's where you're probably going to be doing a lot of setup and use for the sensors that you have defined. So on dead acquisition channels, you'll see I got warning signs. I don't think it will tell me what the warning is until you would say go to load the test and run the test. I do know what the warning is, however, it's that I don't have full-scale ranges defined. So the first one we did some calibration of. We never copied it to the other ones, so the other ones don't have a full scale. We haven't, that's the big problem. We haven't checked the excitation on them. That's not the problem that it's complaining about, because it will have a default. So in range, we can see we have 2,000 for the first one, and we've got nothing for the remainders. So this is where the power of multi-select comes in. So if I shift click, and then I should be able to do fill down, and now it fills down to say everything's there, everything's happy. So you see that every time I do these things, the log will tell me what's happening on a per channel basis. So it says input 2, 3, and 4, the full scale values change from 0 to 2,000. So it gives you a really granular amount of information on everything that changes.
Now, if we're in the middle of the test and the readout from a channel goes over that full scale limit, will it still read whatever it is over the limit, or will it just cut?
I believe it will continue reading past that line.
Okay,
Yep.
so it's not going to just get stuck at 2,000 in the data file.
No, because now I'm not an expert at scale measurement, but I thought that the full scales, it's somewhat arbitrary in terms of the definition of the scaling. I don't think that when you're defining a strain gauge, the full scale value you're putting in here is not saying, it's not mapping, it's not changing the scale factor or the conditioner gain. The conditioner gain is solely based on, I think, in the terms of the internal conditioning here, the gauge factor and your excitation voltage.
This one, the max was like what, plus or minus 5,000 micro strain, and if it ever went above that, it would have recorded. It would just on the data file just say 5,000.
It would oversaturate, but we didn't do shunt calibration on those, or a bridge. What's that method called? Anyway, we could have done it, but yeah, it just shuts it down on that data acquisition.
Well, I should say there will be some limit that you'll hit.
Oh yeah.
Because so back to
When you had talked about
the conditioning tab,
when in high strain there's a compensation bridge, or
well, it's compensating for nonlinearity in the bridge and the gauge.
what's it called? Compensation.
Hold on, it's not in this. It's gonna be in
What was the next window or the next icon?
this guy right here. So use internal hardware conversion unit. Let's find this because I was looking for last time. Did I find it in here? Did I not find it in here? So for FlexStatic, using internal hardware conversion unit strain calculations based on the nonlinear quarter bridge formula. So it's taking into account, it's not assuming that it's just a linear correlation between
The change in length.
right and millivolt output. It's taking a nonlinear portion in that. I think it's based on like I think there's a white paper that Vishay has, which is like the strain gauge manufacturer, because there's different compensations for the different types of bridge configurations, and this is specific to the quarter bridge formula. Whereas if you have the box unchecked, the FlexStack passes the millivolt information back to AeroPro, and AeroPro just assumes that it's a linear conversion, and then just says, okay, here's strain based on what a quarter bridge should be from millivolt, and then it back. So you want the checkbox checked. That allows this to give you a better correlation to strain, true strain. If that makes some sense.
We can play around with it.
Yeah, yeah. And if the checkbox is checked, all of the scale factor information you don't have access to. So I think it cuts you out. Yeah, it cuts you out of all of this information, which I think is also displayed back in calibration.
I'm thinking just if we have that box checked and we're running like tests to really high strains, like nonlinear strains, are they going to try and correct that in the data?
No, so it's
We can hook up one of our strain gauges later on to a channel and see what happens.
yeah. Well, the nonlinearity it's documented based on it's like it's 1,000 microstrain, you're 0.1% off. You're at 10,000, you're 1% off. Or I might be off by a factor of 10 into that, but it's 0.1% to 1% to 10% fairly quickly. Might be 10% at 10,000 microstrain. That's what it is. And this calculation is meant to, or does compensate for that known nonlinearity. So I don't know that there'd be benefit to not use it, is what I'm thinking. Unless you wanted to record it as nonlinear and post-process it yourself later. So,
Okay.
We can compare, yeah, we can do it both ways. But
Yeah.
okay, we'll keep it on.
yeah. So the main things within this is we want to do calibration. So the calibration tab here has a bunch of different stuff on it, from left to right: shunt verify, shunt cal, gauge factor cal, sensitivity cal, slope cal, 2-point cal, lookup table, and polynomial cal. So as far as calibration for using the internal hardware conversion unit, the shunt cal is probably going to be best for, well, it's the typically used thing for strain inputs. So shunt cal will go through, set its calibration internally, and then record the kind of the reference value that you can then use for a shunt verification after the fact. The rest of the methods would be more for if you're hooking up a different type of sensor, or you have a specific calibration that you want to apply, and you know you want to apply, say a lookup table or slope cal, or
Yeah, we want to avoid that.
yeah.
Sometimes a load cell will come in with a table, a calibration table,
Oh, yeah.
And you
But
gotta
for
enter
the
that.
strain gauges,
and then that'd be the easiest way to do it.
yeah.
Yep. So you can set it up.
But
as a
everything
lookup
that we're
table.
doing is going to be with a shunt or
Yeah.
Yep.
shunt verify, whatever that is.
Yeah, I just
So shunt verify is basically saying shunt cal is setting the gain, and then recording the reference value, recording the actual. So when it is shunted, recording that shunted change in strain, so that when you then go back to do shunt verify. So shunt verify is like you've already done your calibration, and it's been 3 months, and you finished whatever test you're on, and you're going to start a new test. You don't need to do another shunt cal. You can check and see what your shunts are compared to 3 months ago when that reference was recorded. So shunt verify is just saying shunt and look at what value I have currently, compare it to what value was there as the reference from 3 months ago when I did the calibration, but don't necessarily change the gains, because the gain may not need to be changed if I'm already within, a happy tolerance value to that shunt reference.
tolerance being like within like 0.1% or something? Like that, whatever you said?
Probably. Reference. Is there a 5% tolerance?
Oh,
But you can,
5%.
you, well,
You can change those.
you can change that.
Okay.
Yep. You can change that to whatever you want it to be. Yeah. So shunt cal, shunt verify being the places that will probably be. So on the shunt cal tab, let's see. So since I've only set up the top one, well, you enable and apply to run automatic calibration. Automatic calibration means that it's going to internally change its gain to obtain it's going to change its gain to read the appropriate internal strain value based on what the calculated strain is from the shunt resistor. Versus manual being, you would have to change the gain yourself. I don't think you can do a manual cal with this. I think it has to be automatic. But I could be wrong there. And then shunt expected. Right now this is all calculated based on what the resistance value is. And then the fact that it's a quarter bridge type, so it's internally calculating, hey, this is what I expect to be a difference. And then right now our shunt reference is nothing because we haven't shunted it to see what we're actually going to get. That's where we have to do an actual shunt reference. Right, and then the rest of them are just different ways to define that. The output of this would then go to the conditioning tab. Since the conditioning tab, if you had this for like a flex test, this would be your overall total gain. You could also see your preamp, post-amp gain here, but since this is all internal to this unit, we don't see any of the scale factors. If it was the scale factor being done up on the PC, then so that unchecked box of use hardware, internal hardware conversion unit, then we can see the scale factor because we're then doing the conversion up within AeroPro instead. Limits, since we don't want things to interrupt us, you probably want limits off. So if you hit 2000 microstrain, so you could just go ahead and turn limits off. Then it disables outer limits and inner limits. Unlike 793, there's staged sensitive limits. Inner limit being tighter bounds, outer limit being outer bounds. Inner is usually a warning to the user and usually like a test pause or something along those lines. Outer being a test stop and interlock. But again, being just data acquisition, probably keep limits off, turn limits off. Now it's probably going to yell about those two, so you see I have warning icons on the left. So if I go to load this and actually run it, it probably would be unhappy with me at that point, and we can find out about that. So conditioning, so excitation here, you can also set these. Still need to find out if we can do in-between voltages. Saturation, I don't think is going to be here. Some of these will only populate once we actually load it. Offsets, so we can do offsets and tears. Filters, same information that was on the previous one, but you can do them for all sensors. Calibration, we were looking through. Comparison is like if you have multiple sensors hooked up to read the same information to see if one or the other is correct, or if one is deviating, then you could potentially have a test pause or a test stop based on those, usually for aero applications or structural that might have dual bridge load cells. So you have two feedbacks from two separate gauge pairs, because if one starts to deviate from the other, you don't know which one is right. If you just have one gauge pair out there, you don't have anything to reference it to, so you don't know if it is actually true
We usually do
feedback.
that manually.
Okay, all right.
Like we'll set up two separate strain gauges.
Yep,
Two
and then
channels.
just watch them.
Yeah.
Yeah. So there might be some benefit to looking at
Definitely.
a compare. And then that compensation, I'm not sure how the compensation signal actually functions as far as how that would function for, say, a temperature for a strain gauge, but I believe that is one of the intentions of it. I don't know if there's a built-in temperature compensation algorithm or if you have to define something yourself for that. And then input resources and then review limits. So, so that's kind of trying to define our sensors, then recorders, where are we? Recorders, if I double click on recorders, it will give me rate information. This, I probably also have to have the test loaded, yeah, in order to see it. So, I'm going to load this and then we'll continue to define it. So loading isn't like I'm done with it. Loading is more or less trying to hook it up to the flex stack so that we get real-time communication between, and then I can set more information on the hardware. So load is in the upper right-hand corner. There's the load test is the upwards arrow button versus unload being the lower button. So I'll hit the load, go to test station 1, and it'll also do a check. So right now it's asking me to test station, right? Test station, if you had flex test, you'd be picking the HSM that this was tied to for control. These are all virtual then.
Right.
So we start with test station 1.
Station panel limited access.
Yep, so limited access, data acquisition function only, or no station panel. The station panel piece being, I think it's a control ribbon.
panel.
Yeah, that'll come up on the top
Okay,
of everything.
gotcha. We
So
don't need
I'll say okay, and then it's going to yell at me based on all my issues. So it does a verification, and it won't let me load. So I got to select cancel. It says 8 unresolved, and it'll show me the issues that I have down here. And yeah, and we can't. So right now, inner input limit detector is disabled. Outer
Yeah,
input
all
limit
the
detector
ones.
disabled. So certain errors you'll be able to ignore and suppress. Certain errors you won't. It's based on the level of the error. You know, so this I
Right.
think is warning. For some of them, you should be able to ignore. So these, in this case, we